Today I'm going to show you what's inside of your car's electric power steering and how it works. Now here's a look at the electric steering rack inside of the vehicle. You can see there's some electrical connectors here that go to the power steering motor here. It's hidden underneath this engine mount that I'm going to have to remove. Then over on this side of the rack we've got the pinion where it comes in here. Then of course the rack will go out to the inner and then outer tie rod. I'm going to go ahead and remove all the bolts that hold this steering rack to the subframe. And take off this mount. So here I've got all the fasteners removed, and I've also disconnected it from under the dash over here. Now down underneath the glove box on the passenger side we have the EPS computer, which is mounted to the wall. It looks like this here, and it's got the plugs on the bottom. You can see the two plugs here that go to the motor are nice and thick, as well as the other two plugs here that supply it from the battery. That's because they are high current. These ones here connect it to the car's computer, and this one to the torque sensor. So here we've got the electric power steering system removed from the vehicle here. We've got our rack and pinion unit here. You can see as I rotate that, the rack inside here moves out, and if I rotate it the other way, it moves in. Now this input shaft here has a torque sensor on it, which is what's going to tell the computer the driver's intended input, and then that is going to supply assisted power through this electric motor here to the steering rack's movement so that you can have power steering. Now some vehicles have a rack mounted power steering motor like this one here, and in some lighter duty vehicles it's actually mounted to the steering column underneath the dashboard. So I'm going to supply 12 volts from the battery to the motor directly, and we're going to see the power steering rack move. And then I can rotate the polarity the other way so we get assist in the other direction. And I tried to connect this sensor to my ohm meter and I do get a reference resistance, however it doesn't really change, so this is not really as simple as a potentiometer. First up I'm going to remove this torque sensor with a couple of 10mm bolts. Just spin that off. Now the way this torque sensor works is actually very similar to the rotary valve in a hydraulic steering rack. I've got another video on how hydraulic steering racks work, especially that rotary valve, so you're going to want to check that out, linked in the description above. Now this torque sensor here has an input shaft similar to the rotary valve. It's not directly connected to the teeth on the pinion over here. Now when this is in a neutral position, the friction of the wheels is what's going to create resistance in the steering rack, and that's going to give you that relative motion between the pinion side and the input shaft side. You can see at full lock to the right here how that ring moves. You can see it's got these two slanted little channels here, so as I rotate it, it tries to twist this, but instead of twisting it, it kind of brings it up a little bit. Next up there's a snap ring inside of here that I need to remove. Now my manual snap ring removal tool doesn't really work, so I'm going to have to use my power snap ring removal tool. And there's the snap ring. Now I'm going to loosen this lock nut. I'm going to try to extract this shaft here. Alright, and I got it to pop out. Now if we take a look at the torque sensor on the input shaft here, you can see as I kind of rotate this, you'll see how that twisting action translates through this piece here to move it up and down, and that causes this metal ring here to move up and down inside of the sensor. Now if I remove this metal ring here, you can see that we have these pair of nubs here, two on the input shaft side and then two on the pinion side, and you remember that these two are going to move relative to each other. They're not actually physically linked together. Now, those nubs are actually going to fall into these grooves over here, and that's what's going to give us a twist and translate action as you turn the steering wheel. Now inside the torque sensor you have two oppositely wound coils which are going to pick up the motion of that metal moving in and out and send the signal out to the computer for analysis. Now the torque sensing circuit is located on that steering box's input shaft, and it's got that piece of metal that's going to move up and down when you twist the steering input shaft. That's going to induce a current in these two oppositely winded coils here, and that's going to be picked up by the sensing circuit inside of the EPS computer. Now it's important to know that this torque sensor is only going to measure the driver's input in terms of how much force and speed he puts on the steering wheel, as opposed to the actual position of it, which you would use in a stability control system, for example. Now the electric power steering system is still a closed loop control system because the driver still has a physical linkage through this shaft over here as to where the final position of the steering wheel is going to be. Once you stop turning it, this sensor is going to stop reading and sending a signal to the EPS computer, and it'll stop sending power to the motor. I'm just going to use my brother's old hat here so that I can wipe off this shaft. He doesn't need this hat anyways, it's not that cold. Now with this mounted in the vise here, you can see the relative motion between that input shaft and the pinion side over here as I twist it back and forth. And that demonstrates that this is not linked to this. A relative motion has to happen so the torque sensor can pick it up and send it to the computer. So I took off that ring that was around here. Should be able to press this out. And this ring just pops right off. Now the input shaft is supposed to be able to pull out from this pinion shaft, but I can't seem to get these pins to unlock, so I'm going to have to cut it. Just pull that off there. Now essentially how this works is you got your input shaft here, it's got two flat spots on it, and you got two flat spots on the pinion side. Now when these two plug in, it gives you that hard mechanical connection, but you can see that there's a little bit of play here, and that play is going to be taken up by this torsion beam on the inside here. So this torsion beam is essentially going to twist ever so slightly, and that twist is what's going to cause that relative motion between your output over here and the input over here, causing the torque sensor ring to slide up and down and register to the computer. Now the rest of the rack is held onto the power steering motor here with these 4 screws. These are actually security screws, they've got a dot in the middle. So I'm going to use my special security bit to take them off. Oh, as I turn it, it makes it go wider and smaller. Now at the end of the steering rack we have our inner and our outer tie rods, and you can see that that pivots about a ball joint inside of here. Peel back this boot here, and I'm going to wind off that inner tie rod so we can get the sleeve off from the motor. And there's the inner tie rod with the lock washer. This is basically just a ball joint on this end and another ball joint on this end with the taper. Now I'm able to slide off this motor housing. Now this motor is just a simple brush DC motor. You can see that there's 4 brushes in each quadrant over there, and that is on the stator. Now the rotor of the motor has the field coils inside, and that's what this big round thing is. Now the brushes are going to contact here, and that's what's going to create an electromagnetic field and cause this to rotate. Now this is going to rotate relative to the rack housing, but the rack itself is not going to rotate. Instead it's going to translate back and forth. You can see when I roll this, that it actually moves the rack out this way, and what's responsible for that is a spiral-like mechanism on the inside here. Now I like this design because it's basically a direct drive. There's no gears or transmission or belt that you have to worry about to link the motor to the rack's movement. You can see there's also a built-in torque reduction because the motor has to move a lot of turns before the rack only moves very slight, which is going to give you a nice power steering boost. In addition, this mechanism doesn't lock the steering wheel in, so that way when your wheel is turning from side to side here, it will actually turn the power steering motor and the full steering rack with it. It's not just a one-way movement from the steering wheel only. In my opinion, one of the best things about electric power steering is you don't have to worry about a leaking steering rack. Typically on an old hydraulic rack there's a seal here that goes, and then these boots get all full of oil and start leaking. I press down on this, it just keeps free spinning. Alright, so I got this steering rack all the way wound out here, but the rack part does not want to come out of this housing, so I'm going to have to cut it. There we go. And this is what the rack looks like. It's got its own built-in bushings to bolt it to the subframe, and it's made of aluminum. So it looks like bolted to that housing is this bearing, which is what allows this rack here to rotate with this motor on the inside relative to the housing. Just pull this half off here, and you can see with a threaded fastener inside here. And with that free, I can just unthread this rack here. And it just comes right out. You can see inside here it's a recirculating ball style. So it's got these little balls inside of here that are going to move in this spiral, and then as this rotates, it's going to rotate against the spiral of the rack here, back and forth, and that's how you turn the rotational motion of this motor into translational motion of the steering rack. Just going to empty out all these balls in here. You can see that these balls are actually really nice and small, and they're exactly the same diameter as the grooves on the rack. And if you ever have to service this recirculating ball mechanism in here, looks like there's a double nut fastener with wrench flats on this side, and then on this side that you have to twist off, and then you can change this bearing. In terms of the actual field coils in the motor itself, this here kind of gives you an idea of the thickness of the gauge of the wire that's wound up in this coil. You've got the brushes that are going to contact the back surface here and continuously rotate it. And of course, because this is a brushed motor, the brushes themselves could sometimes wear out, but the EPS motor is typically not used that much, and I see it outlasting, say, an alternator or a starter. Now next up, we'll take a look at what's inside of the EPS computer here. Kind of cool how even the computers are soft mounted. And we'll just pop off that cover, and you can see that there's more circuits inside. Now the EPS computer is responsible for controlling the electric motor as well as taking inputs from the vehicle's CAN bus and the torque sensor. Now there's a couple of main components inside of here. We've got these 4 MOSFETs which form your motor driver, and they're responsible for switching on and off and reversing the polarity of the electric motor at really high current. That's why this whole thing is really heavy and basically acts like a big heat sink. We also got these 2 capacitors in here. Back inside of here we have a power relay as well as a voltage regulator. We've also got another circuit for the 3 pins that come from the torque sensor, and that'll come into the sensing circuit here so it interprets what the driver's input is from the input shaft. Now if we take a look at the schematic diagram of the EPS computer, you can see right in the middle here those 4 MOSFETs which are kind of arranged in a bridge configuration, and that's going to directly power and control the motor. We've also got a relay over here and a power relay up at the top there that controls it all. So the next time you turn your steering wheel, think of all these components that have to go inside to make it work. Make sure you follow me on Instagram for more behind the scenes footage and subscribe for more videos just like this one.